I couldn't hydrate it, and that it basically was going to be impossible for me to hydrate it. So that's why I am back here again, and why we're talking about it this week, because I'm literally writing the compiler right now for a updated pull-based SSR method for solid. So why can't we hydrate? It's freaking hydration IDs again. Okay. Yeah. Sorry. Comment earlier about the generators. Yeah. To be fair, generators can be a little less efficient, and we could write a compiler that did it, but then like this is just built in, so we can literally keep the same syntax and keep the same thing, and don't need a really extensive compiler. So yeah, async generators. Anyways, where was I going? Solid's use of hydration ID drew some attention last year when they were the only thing that kept it from being the fastest SSR renderer. Solid was even quicker than the baseline implementation being tested against. The reason being that it could optimize escaping with a compiler in ways that dumb template literals could not. So turn them off and win every benchmark. Well, not exactly. We need to hydrate in the client, and truthfully, we need them for other things too. Fortunately, it was only the serialization costs, not the generation costs, that really slowed us down. But it would be interesting to explore what we could do about the topic in the future. Okay, so let's get there. Today in Solid, they're used for two things: stable IDs for resource serialization, which we talked about, and for node matching for hydration. Right. This is the piece that people are familiar with when they open a Solid site like Solid Hacker News. I don't even know. It tells you how long since I've opened a Hacker News demo. Why am I not seeing? It's funny. This is like the wrong repo. I want Solid JS / Hacker News. And let's go to one of my other branches. Let's do Netlify branch. Just see functions. You guys have seen this fun, I'm pretty sure. Let me see. Remember those 001s we were seeing in the React one earlier? I mean, here they are. Hydration IDs. Lovely. They compress well. I mean, but yeah, let's right. But the reason is because of I did a whole stream on this previously about hydration IDs, but because the JSX can be created in any order, conditionals, async, all the reasons that can happen. Essentially, the trick is when we go to hydrate, we collect all the IDs, so all the nodes, and then as the client re-renders in the exact same way, it will generate the same node, and then it like the same ID, and then it will be able to match it. That's basically the trick to our hydration. But the first one is worth talking about because create unique ID resource serialization requires them. And to be fair, React does something similar. This is important for automatic serialization to create resource. Otherwise, you need to provide a unique key or identifier. The only way you could do this would be some compile time mechanism we talked about, as isomorphism, different transformations on the code on both sides would prevent any sort of runtime mechanism from working. What I mean by that is they basically become different files with different hashes. So you have to basically, if you want to inject it, it would have to be compile time before that transformation. The challenge is, if you were to say come up with something to replace globally, like say $UUID, it would need to be presented at the call site. Like the following wouldn't work as it would produce the same ID. Yeah. So this is, someone was mentioning arrays. This is another similar problem. Like pretend you created some kind of UID generation thing, and you said serialize with this ID, this value, and my serializable value. As you can see here, calling this function twice for 5 and 6 would end up with the same ID, right? So you can't compose the unique identifier. You have to actually find every single touch point that would need it. So it's not as enough to be like, I have one primitive where this is baked in. Like I can't just transform my create async or create resource to have a UID. You actually have to go to every single place that someone creates the resource and actually inject the ID alongside it like this. You might be thinking you could be clever and add a counter to it. But if order isn't stable, which is why you want this in the first place, that won't help you and you can end up with a wrong collision. Instead, you need to do it like this. Okay. Which means that the consumption API needs to provide the option. Basically, it's just a convenience for APIs that already demand unique IDs. This way, you don't have to think about what to name things. Less than ideal, but if serialization was opt-in, I could live with this, right? You can be like, oh, if you don't serialize, But definitely a mechanism that works runtime can hide these details short of a compiler going around augmenting all your create async, all your lazy, all your resource call. Problems, it sucks for composition. What if someone creates their own wrapper around create async? Then this falls apart. Like they literally have to use your lazy component. They can't make like my special lazy component wrapper that does, defers hydration or something. Like this is the problem I have with compiled solutions, generally speaking, is like they're very specific and often you have to be careful about how easy they can break. When you have to turn the thing that gets transformed into a special syntax, which is, again, to be fair, like stealth ruins $, that does it. Quick $, does it. You're saying like server $, like this, you're saying that this is not a normal function. It does not obey the rules of a normal function, right? It's not composable, essentially. That's the key to all of those primitives I just mentioned. The results of them can be composable, but quite often it interferes with the they can't follow the idempotent principle, right? I'm not saying that felt ruins aren't composable, but you can't via wrapper create the same thing again, right? Like I often use this example for control flow. Like my for, like in solid, essentially you can recreate where is it, like the for component essentially, but you can go const my for equals props return for props. Like you can conceptually, sorry, I'm missing arrow. You can conceptually do this and return the same thing, right? Same thing with create signals. Same thing with almost everything we do in solid. It has this, I don't want to call it like identity property, essentially. And when you have, let's say, template, I mean, again, this can be intentional, right? Sometimes the language can provide things that can't be composed over, right? But like if you have like hashtag each, if you want to make your own list component, it's going to be a component. It's not going to be hashtag my each, right? Right. Use directive, use server are another way to denote these things. But what I'm saying is you need to design a specific syntax for it that is a language level feature and not a composable feature. Something because when I make use server, you don't get to make use my server. So like there's implications of where you go to these things on a design perspective, right? React was hinting, although I don't think they ultimately went this way, but they were hinting for like their hooks that they use. We use create signal, but like the use signal for hooks, the use could be treated like that $. Like it is a like they left the door open. That's why they told you all to put use in front, because you're like basically saying I'm denoting this is a language level feature. What's cool about use, for example, in this case, is that it can be applied to any primitive. So it actually is, it does have that identity property, right? Marco's tags API has that identity property. It's very, very, very important to us when designing it that and again, this is not important to every system, that there's trade-offs to these design things, but it's very important to us when designing Marco that anything you built could feel first party, like it was the same APIs, like that it had this identity property. So like what I'm getting at is the problem with this, or with what I'm talking about here, is that you essentially get into like a language feature versus a compositional concern from a design perspective, right? Match for addition. Now, this is where a lot of performance is. So alternatives could be awesome. The challenge is that elements in our template can be created out of order. In general, JSX executes out of order. We don't know the parent element over our children. We return our own markup and the parent attaches. In a VDOM library like React, we can construct this whole structure, then perform actions, so order doesn't matter. What I'm saying is in React, they created all the VDOM nodes out of order, but then once they got the tree, that's when they hydrate. Like once it's in order. We either come up with a way to locate the element where they sit in the DOM in a way that the client runtime can find them, or we need to create some sort of virtual representation ourselves, is what I'm getting at. The third option, as I mentioned earlier, is that you could also like not create them out of order, like what Vue or Svelte do. But like for us, I'm saying that's not really an option. Locating with stable IDs is definitely the most straightforward. If we were to try not to use IDs, we'd probably need to serialize some sort of lookup, but even then the order of those calls would matter. Honestly, I think conceptually any solution here needs to convey the tree. So in a sense, hierarchical IDs are just the most compressed version of that information. As we're creating a VDOM ourselves, our code isn't designed to handle one, right? Solid only understands DOM nodes. I do have an idea of that using proxies. We can create our render tree during hydration, then get attached real DOM nodes. This is definitely a more expensive hydration approach, suggesting a proxy per element that server render, but it would have no impact on SSR performance. You wouldn't be serializing it. I did a quick sketch with multiple elements in a fragment as a proof of concept. I shared this on Twitter and Blue Sky. I don't know if people understood this example, but what I did was I pretended that I server rendered this template, right, which is a div with 2 buttons in it, okay? And then I initialized the template twice and just put some values in it. So each button got their text. I inserted it to the app, same thing. So I just did it twice. The reason I did it twice is because I wanted to simulate sorry, you're not seeing this because I cut it off, but this is the div with 2 buttons is a child relationship, and then these 2 parallel is a fragment, because there's basically 2 top level divs in this example. And then I made my own code, made my own hydrate function and get next element, which is like what Solid uses, and a bunch of helper functions for the library. We can look at that in a minute. This is all, and I made a proxy for the element. This is also that at the end, you could create something that looks like a normal counter app that we've been looking at. And you could pretend this is what the compiled output is, which if you look at it is almost identical to the compiled output we've been looking at for Solid this whole time. But essentially count, set count. So there's 2 counters, count 1, count 2, 2 incrementers. And then this is the hydration output. So get next element for that template. And then, so there's 2 counters. See at the end, I'll render it twice. Each one walks, attaches its click handler, called a render effect, which sets, when you click on it, the set content call is basically like a helper, kind of like set attribute. I'm saying like this is like set child. It's just an approximation. But what set content does, if you look here, is if it's hydrating, shortcut it. Otherwise, it sets the text content. So this is just like a helper that sets text content on an element, okay? But it shortcuts when it hydrates, because when you're hydrating, you don't need to set it. It's already been set. So it creates a render effect. And the funny thing is I'm actually using Solid's current. This example is not made with Solid 2.0. This is actually made with Solid 1.0, just for the sake of being able to run it in the playground a lot easier. And then, yeah, we just, as I said, set the text. And you might be like, okay, well, the fact that these update independently and this works is no big deal. But what you have to understand that's missing in this example is we never render the actual DOM nodes. If I remove this template, this should still work. So So like what I'm getting at is the rendering happens in my fake server setup here. This basically is calling get next element. So this is like our hydration thing. Now in the past, we'd look for hydration IDs and get the element off there and then link everything up. So what is this doing instead of getting hydration IDs? Well, what it's doing is if it's not hydrating, it just clones a template, which makes sense. But otherwise, it creates a proxy element. And what this proxy element does is, I mean, this is where the complication comes, but it actually intercepts append child calls, first child, and next sibling calls. And as it walks, it creates other proxy elements. So basically, this is a proxy of an element. We don't actually have the element yet. This is a proxy element. This is an element. Even us attaching this event handler to this element, if you look at the setter function here, it just creates an object where it, see, if you already have an element defined, it will update the element directly. But otherwise, it creates an object and sets the property on it so that at a later point, when it gets inserted, this is the key, when it gets inserted to the parent, and if it hasn't defined its own element, it basically calls the elements append child. And then node element this, sorry, if it doesn't have an element, it just calls the append child. But once it's been resolved, once it does have its own element, it uses the index of like where it is, like because at this point order doesn't matter anymore, to actually grab it out of the child nodes and match it back up. Now, this is incredibly complicated, and I'm not saying that this is a good approach. I just wanted to show that it was possible, at least, that we could literally create a proxy, build up our DOM here. At this point, even when we set up this render effect, these are not even real DOM elements. And then when they get attached, like in the hydrate call at the top, when we do the render, when they actually get attached and they call the, basically this would be an insert, but they call the append child, because this first element is actually, even though it's a proxy here because it needs to intercept, is actually defined, because when you call element here, it is like a real DOM element. Once it, at that point, it goes through, calls the append element call, which I show here. Where is it? Append element, and actually goes through and goes, oh, I do actually have, the element, or, or I don't, like, and basically realizes all the DOM nodes. This is just complete craziness, as I said, but it is interesting that we could take the almost exact same code Solid generates today and actually have no hydration IDs and basically match it up by letting it basically put itself in place, and then use the fact that, like, now that we have this tree of virtual elements, as we attach it to the parent, it should be the same tree in the parent, which means that we can just upgrade all these proxies to actual elements. Yeah, it's kind of, yeah, and it's invisible, yeah, because like these all look like normal DOM node calls. And once you've got your element, what you'll see is the proxy. If target element reflect blah blah, it just passes the stuff straight through afterwards. And any new element created after hydration won't actually create a proxy element. It'll create a real element, and so this only affects the elements that are there at initial render. And after, so there is an extra proxy through every element access, which would be expensive, for stuff that's initially rendered. So again, I don't know if this is a thing. I just wanted to see if there's a way that we could literally in place, like, generate code that works perfectly fine after the fact with real DOM elements, but at hydration time, temporarily basically run a proxy through it. Yes, as I'm saying, this would definitely be impactful to client performance. That's why I say there's no wins here. There's only trade-offs. So you make your SSR faster potentially, and arguably more stable, because the difference here is the hydration mismatches aren't the hydration is based only on what gets inserted, right? If someone makes a bunch of proxy elements and then never attaches them, um, that's okay. One of the problems we've been having with Solid is people inadvertently don't realize that they're making wasteful elements, and they update the counter, and then they don't insert them, and then elements are and the DOM's only aware of the elements that are there. Like you can't hydrate something that wasn't inserted on the server that isn't part of the tree, right? So like this actually guards from that. Funnily enough, um, again, I'm not saying this is necessarily a good idea. I just wanted to prove that it was possible. Oh, sorry, reusing my client. Perhaps a question, but what's the benefit of having composability when the risk spectrum? No, no. I mean, composability is like one of the best properties we have as these frameworks. I mean, don't get me wrong. Maybe that isn't something that should be composable, but like you can expand out. Like Dev's already done this, like with like use socket or use like he's been building special server component esque. Uh, like we have use server, right? And which is like an RPC call, but he's been making specialized things that define the different export type. We have a whole stream about this. I think this expandability is a very, very, very good thing to treat everything as if it's first party. I think it's incredible. Will it leave more options in the ecosystem? Yeah, but like I love old React. I'm sorry, like that was my favorite part about React is that there was no single router solution. No this, like I know this is all about what I was talking about at the beginning. People want to eliminate the noise at the cost of what's good. This is like it's like like capitalism. Like it's this is like the idea that the hopefully solutions of the best qualities will survive over time. Survival of the fittest. You got to give people the ability to be able to make better solutions. Otherwise, you get stuck. Getting stuck is terrible. Yes, yes, and it's why people like Tanner and Tanstack are such huge fans of Solid. But I think the problem is it's nice in principle, but then when it gets to putting it down to actually doing the thing, it's actually really hard to accomplish because you have to make other compromises to be that general and generic. And at a certain point, you just want to get a nice solution out there, like RSCs or whatever, and have it just all work a certain way. And then it's like you have to, educate people and teach them like this is the right set of trade-offs. If there's danger of being too powerful, of like giving people too much power, right? There is a balance to be made here. So I get it. Um, I just think that we've been taking the power away too much for the last little while, and I don't know what to say. I think I like the idea of building a framework like Solid, which is like innately the most powerful, right? Like it just has the most capability, right? I mean, I don't know. Everyone has their own kind of preferences on these things, and I realize this is I realize this actually because of my playing in Magic the Gathering and people having different decks and different personalities and different like things that appeal to them about the game and metagaming and how they approach it. It's a very complicated system. And when I look at frameworks and people like that and like stuff like that, I see a very similarly complicated system. For those who are interested or want to know, just to give you perspective, as a Magic player, I play Gruul. Unapologetically play Gruul, which is green red. That might mean something to some of you guys, but I make Gruul work in any format. People could be literally killing the mana dork every single game over and over again. I'll make that so it works to my advantage. Right. So yeah, it's a value. It's about values. Don't know if I have any Magic the Gathering people in the audience, but yeah. Yeah, and catering to the thing, pit of success. I'll hear about all the stuff of how we can onboard the greatest number of developers. What I think is interesting though is Are we going to a place where teams are getting larger or smaller? Right. Don't get me wrong. I don't think AI and these technologies are going to actually necessarily like reduce the number of developers we need. I think we need a lot of developers. I just think developers are going to be in smaller teams, are going to be able to capable of tasks more independently. And I think in those situations, and if you want efficiency and stuff, like I think this mentality makes sense, right? Like a lot of solutions for scale are because you have to solve the scale itself, micro front ends, like, so if you can alleviate that tension, then you can do more incredible things. Big Mean Green. Yeah, I mean, I'm a bit of a Timmy Spike from that perspective, but yeah, Big Green's okay. I like aggressive mid range. I like mid range decks that look like they're mid range but kill at aggro speeds. Basically, I like decks that are incredibly aggressive, but they don't fold to like a singular removal. Like every card is the most efficient possible in terms of like power level. Like it's not about ramping. Ramp's important for tempo, but not for size. It's not about landing the biggest threat. It's about at key points of time invalidating positioning by just having something that's so overwhelming that it has to be dealt with every turn, and then purely basically using virtual card advantage. Anyway, sorry. Again, Magic chat. Maybe I'll do a Magic stream sometime. But yeah, I'm kind of a brute forcer, and I feel like maybe that reflects in my work on Solid. I force solutions into play. I have an idea of how to make things efficient, and then I force it into play. Yeah, I don't know. Anyway, let's keep on keeping. So why am I talking about this now? I was going to leave hydration until later, but there's a problem I'm realizing generating IDs. Consider something simple like this. Div, condition, comp1, comp2. And for reference, this is what it generates on the client side for hydration, more or less. Get next element, insert something, memo, condition, blah, blah, blah. And this is what it generates on the server. Condition, escape, create component, right? So I've compressed it. I'm showing like, here's your div here, here's calling a create effect, essentially. Like here's your element, here's your memo, some components. Okay. Now, let's consider the difference between Solid does today and what Solid could do in the future. Let's say the condition is derived from something async, like this showing different components based on whether the user is an admin or not, right? Okay. Now, when I want you to notice that there are no reactive primitives in the SSR version. There's not even like a reactive wrapper because we don't care. Like if condition changes, we're going to just be re-rendering it all over again anyways. Where this version, there's like it's wrapped in a function, and there's a memo wrapping the condition to see if it's true. And you get what I'm saying? Yeah. Yeah. Oh, yeah. In terms of use servers, yeah, yeah. And to be fair, these are values that I shared originally with React. I think it's just a very, very important capability. I don't like my hands being tied. This is the thing you have to understand is when I sometimes wonder. I'm older. I don't than a lot of the people who actually slightly older than a lot of people who actually build frameworks. I I got in this game late. I was already like 35 when I started building Solid. Um, I guess no, I guess that's not true. I started building Solid when I was 32. I open sourced it when I was 35. But like a lot of people, I'm not all of people's journeys are the same, but a lot of people got into the framework building stuff. I feel like at a younger age, they were really smart kids out of college, and then they got hired by a large company, and then after a few years of doing stuff, they get to about the 5-year mark and they're about prime for it. So we're talking about like 26, 27 year olds generally being like the core age of like big movements on these frameworks. And for me, like this is like 32 to 35-year-old me making decisions. So my perspective of what I was trying to accomplish was, very, very different. So yeah, I don't know. I think it reflects in this. But okay, let's continue on here. Okay. So now I want you to notice there's no reference. Did I share this document yet? If I haven't, I should. Solid today doesn't even bother wrapping the condition of the function because it needs to render independently. In solid, we re-render components on the server as a suspense resolves. So even if the state condition changes, it doesn't matter. Still, we do need it stable for async between runs. So if there's a new create resource, we can pick up the already created promise. It's possible to rerun the suspense to rerun the component that creates resource. So this is why we use hierarchical IDs. Okay, so in the same location. So while imperfect, it actually works pretty well using components as our nested level. Like show component is fixed regardless of what path goes. So it registers as one and the next sibling can be two. What I mean is in this, like if we had a show component here, for example, like instead of this ternary, I'm using a ternary on purpose, but you could see that no matter if component one or component two got chosen, the show component means that any sibling after the show, like show could be one and then the component after could be two. Like any component after it would keep treat regardless of which way, because this would be 1-1 and actually they'd both be 1-1 depending on which way it went, essentially, because we're nesting at the show component level. However, if a conditional is a ternary like above, it might mess with things if the number of elements it returns differs, that this would impact siblings. Luckily, people generally aren't fetching resources really deep under a ton of conditionals in their apps. If those conditionals change, you would expect stuff under them to be thrown away and refetched anyways. And mechanisms like query caches give us, existing promises other ways other than using the serialization ID. But what I'm getting at here is Solid's current approach, which is basically at every component nest a level and then does a counter, actually has a bunch of edge cases. People just rarely hit them. I think it would be clear looking at this, if we want a solution that can handle fine-grained polling, like separate things, it has to be finer than components. So what? Well, the ownership graph of reactivity works pretty well because it's where all the decisions happen. It would be much deeper than components, but we aren't serializing one place. Maybe it doesn't matter. And actually, I've been testing it. It isn't actually that much deeper than components. A lot of times people have more components in between than they have decision points in the tree. I'm actually finding that the hydration IDs are actually shorter. I actually implemented this ID system in the latest builds. You have to pass it to the owner, but it's really fun for debugging to have every node have an ID. So you can be like, oh, it's 001 that updates. Like, oh, what's a dependency? It's on 002. Like, I know that's kind of weird, but actually, like, we already had naming for convenience for specific nodes for debug, but now we could turn it on so like every node has a number. Anyways, where am I going? More so, if we were ever to serialize our reactive graph, this would be part of it. Like if every node had an ID, then the rest would be pretty easy. This would unlock things like resumability and easy serialization of any computation we felt was too expensive to run on client-side hydration. Yeah, so here's the thing. Resumability uses like a very crazy compilers anyway, so maybe it doesn't matter. So it injects all the call side IDs and uniqueness like I talked about. But technically speaking, with this mechanism, we can basically, because every node has an ID, then we can be like, okay, this node value is X and it depends on this node and this node, which means when we go to hydrate, we don't need to rerun the node on the client. We actually know the dependencies so that when that node like registers, it can like link up the thing without running any of the component functions because we have the value. And then we go like, okay, I depend on this. Well, let me add my node to the other node. Like you can build the graph back up without actually running any of the user code. However, we have a new problem. The graphs have more or less to be identical on both sides. And you can see from above, they aren't, right? Because if you have ownership, if you look, I mean, I drew it again. This memo is now adding a new ownership. Like this inserts a new ownership and we had no ownership. Right off the bat, there's an insert which creates a render effect. And there's an additional memo, which around a condition, which we don't need either on the server. The render effect would cause an additional nesting level and the memo would offset the counter used for other components. Even if we added those, what about this template? Disabled. What I'm showing here is that the order, like we group effects together. So the order they appear in the HTML is not always the order that they appear on the client. What I'm going to show here is we actually do the insert before we group all the attributes together. And then we have a separate effect for the value because we treat the value property on an input special and it runs afterwards. This is and it's handled separately. there's very good reason for this. It has to do with like ranges on like certain types of inputs, and like I'm just saying there's a bunch of rules, okay, because of the shape of the DOM. So the first expression is the first value of the H1 getting inserted. The second is the attributes on both, and then the last one is the value. These are way out of order, but intentional, so that we can set the value last, and even elements like options. That's another good example. And we do it independently, so it doesn't need equality checks. Other property attributes are grouped, and we handle inserts separately. Whereas in SSR, we generate this with wrapping expressions and functions, right? And you can see that the order is not the same at all. Like we actually smartly put the value and disable together, so we didn't need as many template strings. We actually just added them. So like we actually try and put as much static parts together as we can in the template, and then group all the holes the best we can. This grouping is by order and not by behavior. How would these be done efficiently with the same shape? Maybe something like this. So this is what I was talking about, creating a new compiler, which basically reasserts the client ordering, where we have the insert first, the attributes, and then the value setting, and then creates them in this order, and then inserts them in the template at the end, back in the visual order. Because again, you're creating a string, so it's you have to get them back in order at the end to actually output it. Each resolve would create a new owner in that order and attempt to flatten their expressions. If they hit something async, then return not ready. The SSR knows how to handle it and creates the return template object, like we showed before, the whole pulling thing in the last write-up. Honestly, I don't know if performance would be that much worse, but I suppose it's worth a shot. It is interesting that, in a sense, SSR render would be able to group things almost identical to the client universal renders, and it would just be the final output that would be different. That being said, is server becomes even more dangerous here, because previously it only really messed with resources. You know, like if you didn't have the count be the same, like if you tried to create like a signal only under a used server, but now it can't wrap any reactive statement unless you know you're creating the same on both sides. Yeah, we see that we can see that you want. Does the Svelte playground actually show? It shows no. It shows the. I mean, I can't tell. I mean, it shows the. I don't. It shows the output code, but I don't think it shows the output result. Like in solid playground, I've been using this the whole stream. We're showing here we have the same switch: client side rendering, server side, client side retention. We show the output code. Yeah, yeah. I don't know if you ever noticed that one before. Is that what you meant? Like this is what I've been using on the stream here. We actually even show the universal thing. This is shows like what it works when it like if you use it with 3D with 3 fiber or like terminal or whatever. You have the universal output as well. Yeah, I mean these all have overhead, right? I actually think the IDs are one of the more compressed way of doing this mapping, because it's a hierarchical problem, right? So the problem is, like, I tried to currently, so we do a component level, we introduce this, but then as it's mentioned here, the component level is imperfect. The only thing that is actually perfect is if you match up on the reactive graph, but then the client and server have to basically resemble each other in terms of graph shape. I missed this one. Server render. Generate. It's funny. The option call it generate was something I actually got from Svelte too. I mean, you don't see it here, but the option actually in yeah, because let's look at Svelte. We've been looking at server. The client version is on click handler, set template effect. See, the render effect's called template effects, pend anchor. Yeah, okay. Looks good. Anyway, but I'm just continuing on with this. Oh, do you know why the increment? I was trying to wrap my head around the basic counter example, why the increment shows unused on the server installs playground. Because this is because it's smart. Because you can't click it on the server, right? So the server results don't need to add a click handler. So because you can't click it on the server. So technically a smart tree shaker can also remove this function altogether because essentially there's no click event to register. Sorry, just a second. Might have missed a call. Usually I don't check this on stream, but no, doesn't look like anything. Okay, cool. So anyway, yeah, where was I? Yeah. No, the derail's fine. Where was I? Each resolve would call the owner, blah, blah. Honestly, I don't know if performance, yeah, okay, where we were. So back to the beginning, if we want to keep hydration IDs for serialization, case one, and remove them for template matching, there's a potential for solution here. It just perhaps less performant on both sides. We sacrifice hydration performance for removing serialization costs of hydration IDs, and we sacrifice server rendering performance to get better stable IDs. I would say both solutions are probably more sound than their predecessors. Just funny that they're almost nulling out all the other, each one's like nulling out the other's performance. One makes SSR slower, one makes SSR slower to be more accurate, and the other one makes hydration slower to make SSR faster. Do you know what I mean? So it's like, but like anything else, we don't know until we test it. Anyways, yeah, it's one of those things where like I think the solution is probably better, but it's like, is there a performance hit here? And don't get me wrong, I've been lamenting this performance hit. To my best of my knowledge, it's still like 3 times faster than React. So like at least the hydration one might be worse, but the server rendering ending these things is still faster than like all the VDOMs. It's just like, is it slower than Solid today? Yes. Is it slower than Svelte today? I think so, slightly, right? Solid still like, so like this switching to this would definitely be a hit, but it would open up, it'd be better. So I don't know. We'll see. Anyways, this is where I've been working. As I said, I made a compiler. I've been working on a compiler for this new output, and this is kind of like the basis of what I wanted to talk about today in terms of SSR. So before we go on to a couple other topics, I thought maybe I'd show off actually, you know what? Maybe is a good time to go on to a couple other topics. I don't know if I'm going to do this week in JavaScript in the typical sense, because I told you most of JavaScript conversation and this week stuff has not been particularly interesting to me. But there's been some proposals or new work in other frameworks that I think we should talk about. Is having unique node IDs continued on this new hydration mechanism? Because it seems like those would... No. What I was trying to say is the IDs are needed for serialization regardless. Or for like of resources and stable IDs and all that kind of stuff. So we're creating the IDs anyways, and I've actually created the mechanism in solid signals right now. Solid signals, and you can turn it on by whether you put in the root, but the gist of it here is one of the things I did when I was working on it is I actually built a pull-based reactive system inside Solid. People know that classically, when you import create signal on the client, it's the normal one, and when you put it on the server, it's like this not reactive one. Well, I've actually been building a pull-based system, and the interesting part is even the ones that are like the non-reactive pull-based system, they use the same ownership model from Solid Signal. So you actually see us sharing more code, and that means that like class owner here has an ID which can be set, and then if it's set, when it basically and it's the current owner, when a child's created that doesn't have an ID set, it actually has this get next child ID function, which is actually calls this format ID based on the current parent ID and the current child count. And if we look at here, the format ID is actually very similar to what I've been doing in Solid 1.0. It basically uses base 36 to string to convert the numbers. So instead of each digit only having 9 characters, you can go up to 36 characters. And then if the length is longer than 1, we add a delimiter character from the capital character case sets, because these are all lowercase. So basically it goes 0 to Z. And then because we get to reuse the same ID generation and stuff, I'm actually kind of, I'll show it off. I think this is actually kind of cool, which is not true about solid previously. But if I go to the next branch and look at packages, where is it? Solid source server. If you look at the there's a signals file, which is basically filling in like the signals library. What you'll see here is that the code is generally a bit different, though we do have like create memos and stuff, but it's using its create memo. Let's see, where's its create memo. It actually looks a lot like the internals of the signals library, because it's actually using owner and get owner and run with owner. All the owner APIs are actually the same as the client side ones. So if someone does want to have reactivity on the server, they could import directly from Solid.js signals and have the non-reactive and the reactive versions working together in the same cleanup and ownership model, because it's literally the same base. Reactive systems are really 3 parts. And I talked about this in a previous stream. It's very cool to see this happening thing, because like with the pull-based system, we don't need the advanced scheduler. When we don't need the auto tracking, but we need the ownership model. So we're using the ownership model. But all 3 parts are kind of quintessential into how React systems are getting built today. There's now like an ownership model that's the baseline primitive that the dependency tracking gets basically inherits from. And then when you add effects on top of that system, that's how you add the scheduling in. So yeah, the amount of shared code is actually increasing to the point that other than the signals implementation, it's theoretically possible the rest of the Solid doesn't have to differentiate from client and server, as long as it's like optimal enough. See, part of me wants to do stuff like, and I guess it's a part of the signals implementation, but like mapping, for example, is a place where we can do much more optimal stuff on the server, knowing that it's running once. So like I don't necessarily want to use the client side one, but beyond that, once you kind of go out and compose on these primitives, since they use all the same primitives and there's an equivalent version on both sides, like the code doesn't need to be any different anyway. But where I was getting at is that, yes, the IDs are important for a bunch of features. It was the cost of the serialization. So we can continue to serialize the IDs in the template, or we can do that virtual hydration proxy thing I was talking about. The challenge, as I said, is the pull-based reactivity. The thing that I didn't write in this is that I need I can't keep on using the component-based approach. Like I can't just throw this away and use component-based IDs with the current model because of lazy evaluation. Basically, when we knew that memos always acted eagerly, when you went create component memo inside, you knew not only that it was created under that scope, but it actually ran first under that scope, which means that it would inherit the ID. So you could do something in the component that's like, it's in Solid's current code, where it's like set hydration context, run the component, set parent hydration context. Like you could basically just wrap it synchronously, and you know that the code would have run in between. But now, because it's lazy, it doesn't run until it gets inserted, which means that component style wrappers don't work, which is why even if we're using a rerun model, we still need to basically inject the ownership context into the tree, which has a performance cost. So we're kind of stuck regardless. I didn't bring that up here, but this is why, this was the end of what I was trying to say here when I was talking on Twitter. This is why I can't wait till later. Because essentially we're kind of, because of the other design decisions on the client side, we just have to move forward with this direction. And we want those things. Like this is all a matter of scale. I can be disappointed right now until I find the solution, but it's not like we're talking about a bad solution here. It's not only better, it's still more performant than the most popular solution. So it's like, what am I complaining about? I'm just very picky. So anyway, yeah, let's continue here. Okay, so yeah, let's go to Twitter. I think the first thing I want to talk about today, no, not the notifications, is sorry, bookmarks, not AI. That's not the first thing I want to. I'll talk about this blog, React Labs, View Transition Activities, and more. I don't know if you saw this. This is actually really cool stuff. I've been really enjoying the stuff that React Labs has been putting out, and I think we should we should we should look at it. Don't worry, guys. I will do Svelte next. I should have enough time. But yeah, I think this is interesting because they're basically proposing 2 experimental features: view transitions and activities. And if you haven't seen this, it's worth a read because it's a different take. This is a very incorporated take. It's funny when I looked at view transitions integration in Astro, it was like very incorporated. It was just like here are tags, just everything works. Then SvelteKit did the other approach, which honestly I admit I would have gone that way too, which was like just give the hook to the end user and let them do whatever the hell they want. So basically, as long as you time it right, so that when you're rendering, that you get it right before you like commit your effects, then the end user can do anything, and it's very, very, very powerful. So again, a very powerful API. React has chosen to do more like Astro's approach, actually, but considering all the other async primitives they have. So it's actually very complicated, but very powerful if it works right. So I'm going to admit view transitions are not what I'm most interested about in this blog post, but I think it's worth looking at here because what their idea here is, okay, what to opt into animating an element, rapid and new view transition component. Okay, cool. This new component lets you declaratively define what to animate when the animation is activated. You can define when to animate by using one of these 3 triggers and view transitions. Start transition, use deferred value, suspense fallback. Okay. This is an interesting one for me. It's that I don't know, like this easy to understand. You're just wrapping something view transition. This is always tricky because I mean, suspense is easy to understand. It has a fallback and you do it. But these 2 are interesting to me. And I'm going to be interested to see how much the general React audience knows how to or when to use these. This article is not aimed at the general React audience, to be fair, but more advanced users definitely. But like starts a transition. But again, I don't think most people think of starting their state transfers as transitions. Luckily, this is built into most routers. Like most routing should be a transition, and you probably will never touch it yourself otherwise. This one's interesting because this is use deferred value is like latest. We have something similar in Solid, and it's something that you actually need more often, but you kind of have to be aware of what's going on first to do it. So most people don't even realize they need to use it. So this has actually been a big part of my async 2.0 journey, is figuring out how to like make this stuff make sense, and we'll talk about that more when we talk about the Svelte stuff. But these being the triggers is interesting. On one hand, it means that routing should get view transitions by default because it will be built in and then people just put it in. So that's a win, and that's probably the biggest win. We can pretend that no one will ever use this, even though they probably should. And then this, some people will put this in sometimes and it will probably work. So I think it's interesting trying to just like understand the implications of everything. So let's continue. By default, these use CSS, blah, blah, blah. The other reason I'm interested in this API is because Solid and React classically have not have built-in transitions, unlike Svelte, which does. So having like we have like transition groups. Vue has that first party. React used to have it first party and then kind of shifted out. Solid has one that I built in an afternoon looking at Vue and probably haven't touched in like 7 years. So and there's also like Motion one, and we have like third party ones that are actually good. But I'm just saying, like, as a base level, it's interesting from a core primitive, being able to bring this back in. Yeah, so there'll be some libraries that will build transitions in. I'm just saying, you as developer, it's hard to picture you ever using that API. you're familiar with browser's view transmission whenever it supports it, blah, blah, blah. I don't care too much, but let's see here. When we click into it, is this without it? Yeah, maybe this is the without it version, right? They just show some examples. Okay, let's just use router conditional, blah, blah, blah. User meant to use navigation, animating, right. Navigate. Yeah, they're showing it built into the router. This makes sense. And then, yeah, okay, I think I saw that one this time. You guys probably can't see it, but it's actually fading. View transition, wrapping it. Okay, yeah, so they're showing you how you use it. That makes sense. So that seems simple. I like it. Seems like a win. You can opt out. Makes sense. Default none. Customizing animations by default usage includes crossfade. That's nice. I think this is a win. Like it seems very simplistic way of doing it. Shared element transitions. You give it a name. Is there an example for this one? I'm kind of interested. Oh, that's cool. You see, I mean, it's probably coming in small, but the way it fades in on the same thing. I think this is a win. I think everybody probably. It's always interesting when you see stuff like. But if you picture that all your anchor tags are going to have this already basically start transition built in, you can start to see how this actually works out. This is a very smart system. I think the thing was when I first looked at this article, I was just like, what? Yeah, okay. You can add cause, navigation forward, nav back. This feels like it's an instruction manual for people building routers, which is good. This is actually the people who need to actually pay attention to this. Although you will have to express this to the end user, how to, like, hey, if you want your view transition to only happen forward or backwards, make sure to put share nav forward on and put your class. But I think that's okay. Yeah. Animating suspense boundaries. So we'll activate view transition to animate, fall back to content. We can suspend with the view transition. Yeah, so you put it outside. So this looks like old transition group, I'm gathering. And then, so yeah, so that you can't see it very well because it's, but this fades in on the fallback. And then if you put it inside the fallback, you also have a separate slide out one, right? Okay. Yeah, they faded in and faded out. It's hard to see in this example here. You probably want to, if I didn't share this already, I did. You probably want to look at this yourself. Animating lists, put one on each key. This is pretty cool. I think this is one of the coolest things I've seen in a while, actually, out of the React stuff. This is actually, it's like, I guess, finally a version of transition group that they like. This is very cool, and it helped. I think there's been a lot of criticism about React not paying attention to the client. This is a client only kind of feature. This is actually really good. Yeah, because when I first saw the API, I was very much on the Svelte kit side of things, where I was like, I can just put an await around start transition, and then ta-da, I've given people that hook, right? Because, like, let's face it, the audience for this is mostly like the router, but they did the same thing they did with suspense, which is smart. No one needs to write transitions or use deferred value probably, but everyone just writes the transition component like they do suspense in their code. So this is all you really need. This kind of inversion of like having the one API hidden and then having the other API just kind of work is really good if all the libraries participate in this, right? If you can encourage their libraries to do the right stuff, then people will get this benefit out of the box, and it's a sensible behavior. I like it. That's very cool. Activity. In the past, we shared where we're searching API to allow components to be visually hidden and deprioritized, preserving UI state and reduce performance costs relative to mounting or hiding with CSS. Now we're ready to share the API and how it works. So now you can start testing in experimental React versions. Activity is a new component to hide and show parts of the UI. When this activity is visible, it's rendered as normal. When the activity is hidden, it's unmounted, but will save its state. You can use blah, blah, blah. Don't mount when the activity is hidden. Yeah, so this is off screen. I think Yeah, I mean, you can just wrap each one in an activity. The name activity is weird to me, but it's fine. I guess it's better than off screen because it can be on screen or off screen. But yeah, so they wrap each one, and then basically, if you wrap each one, then each one would get. It's almost like they're both there, but they're not like completely live when they're off screen. Pre-rendering with activity, yeah, like basically because you are loading all of these. If you do that, so I saw some people respond to this and talk about how this is awesome for routing. The truth of the matter is, there's two different types of control flows when we come to conditionals. There's show, this is show or suspense, and then there's like, or I mean, you can argue this is switch match, and then there's like dynamic, like our dynamic component where you're just swapping one thing. Routers are usually dynamic. They don't. By default, routers aren't like if this show this, if this show this, if this, because the list is dynamic. So literally, it's more like match on URL render components. So they don't flatten out like this to do preloading. It'd be interesting if on a per route section hierarchy level you ask the question, but usually like you don't know 1 or 2 or 3 or 15 or 100. So you're generally not doing this. Like for a fixed set of tabs, you are doing this, but you're not doing this for most things. I actually think transitions are a better API generally for routing than this. This is good for like tabs. Yeah, keep alive. The activity, visible, feature modes. Yeah, hidden. I think it's interesting. I was so interested in this after reading blog post. I re-implemented it in Solid 2.0 demo. Let me see if I have that here. I didn't call it activity. I already had this. I just tried this hidden and visible thing that they're doing. Because essentially, I called it boundary because technically suspense is a boundary, error is a boundary. This is a different kind of boundary. It has the same idea of scheduling, right? Because what this boundary is saying is like when it's when it's bigger than 2 or smaller than 5, it's hidden. Otherwise, it's visible. So when it's visible and it's reading something async, when we load, it's loading because it triggers suspense because it's visible. And then when there's like a 1 second delay on this async. And then when it gets bigger than 2, it disappears. And then when it gets 5, it comes back again. I guess the problem with this is it's really hard to show when rendering actually happens, right? Because if I go in here and console log in here, we're going to see it because it's on the pure side. This value will update while it's off screen, but it won't update the detached text node because the effects are held, but the reactivity system is still present. So I don't actually have a good example of this actually in action now that I think about it. But yeah, I just made boundary component under suspense. I guess like if we said it was hidden until it's 5, this is an interesting one because if it's off screen initially, it's like, did I break this? And we found our first bug. Lovely. Because in theory, it's funny. I tested this in the solid playground without the final component, and I thought I had this nailed. Because basically what I'm saying is if C is smaller than 5, it's hidden, which should mean that suspense doesn't trigger, but I wonder if I've actually killed this whole thing. This is the fun part about, okay, no, I haven't. Yeah, because I'm going to have to look into this. Before I had the exact same demo, but done purely with in the playground with like no compiler. So it's like, okay, loading, and then I put a counter that increments. Disappears, come back. But when I did it and I removed this, at least in this version of the code, oh no, that's funny. I broke it. Anyways, not important. What you see here is what I wanted to show that you can see in this demo is creating div happens initially, and then even like when we reinsert it, it doesn't create the div again. See, it's back. It doesn't like this console log create div only happens initially. So I'm showing the alive 1, alive 2 is inside the effect. when it's off screen, it's not firing the effect. So this kind of is the proof of concept. It seems that I have a bug forwarding suspense that I introduced at some point, that I'll have to look at. But what should be happening in this scenario is when it's off screen initially, it doesn't actually trigger suspense. I guess the reason this triggers suspense is because it's doing the read up here, which means they're both triggering suspense. Like if I didn't want this to trigger suspense, I would have to do something like this: count like this. Then if I did this, see, the timing here is going to be interesting because it's going to disappear now immediately, not when it finishes loading, which is fine. So when this goes to 5, it's going to show even 4 before it loads. But with this scenario, if I remove the count is bigger than 2, and it starts initially hidden where it doesn't trigger suspense, you saw that it loads immediately, and then now it should show up in theory. But oh no, it has to get up to 5. Sorry, my bad. Now it shows up. I clicked it too fast, but you can kind of see that. You notice how like when we clicked it here too fast, you could actually see the previous value here. It's interesting because it's because technically it's still live off screen, but it's not updating the DOM. Like the reason it showed 2 was because that was the last. No, actually, no, that's interesting. Why did it update 2? That's actually an interesting question. It must have at the time. No, it is at the time that it goes to show it. It renders the DOM with the value that's currently there. Which at that time happened to be 2. It actually didn't render it off screen as we already showed here. So this is an interesting thing, the interplay between this and async with tearing. But aside, okay, it was fun. Render effects run at least once when they are part of the active graph. And yes, they do run at least once. Yeah. Yeah. It's funny because Magic has its own vernacular, right? Like just like programming does. Okay. Anyways, in general, I think we're going to see a lot more of these things. Just understanding like let me see. If I go in the signals package, I actually did a lot of work here under what I call boundaries. And what you'll see is, funnily enough, I have all the different kind of boundaries here, but create suspense. It creates what I call a collection boundary. Create error boundary also creates a collection boundary. And then this is what create collection boundary. And then this one here, create boundary creates create bound create. Well, if I spent the time to go through this, a lot of the code is almost identical. It's the exact same patterns for creating all of these types of primitives: suspense, errors, off screen, or whatever you want to call it. They actually use the same mechanism of producing their own effects queue to hold effects, and then create their own, what I call it, I don't know what to call it. It's a boundary computation, which is designed in such a way that it both can collect all the nodes underneath it, and it also, any top level throw or whatever it can grab to. It basically isolates the change. And the reason this is important for stuff like off screen is because when off screen is off screen, it still has to handle async. It still needs to like know not to leak it up or whatever. So while my demo didn't work quite the way I was hoping to in that example, and I have to look into what the bug is, generally speaking, these are all actually the same thing. They're a mechanism for isolating an execution and then managing an effects queue mechanically. So it's really interesting to think of like how many different applications. I actually came up with an application that I thought would be really cool, that I ended up throwing away. But it's going to be relevant to our next topic, which is that one of these applications that I was thinking about was was what if we create a control flow that looked like this? Transition, right? And this isn't a view transition to be clear, but that's a transition when route.url and then URL is pending. Okay. Because I'm always looking at getting rid of use transition. I've been looking at getting rid of use transition for ages because, as I said, no one really knows when to use it. And I was like, what if we could like do something like this? So you could like draw your route and then like, you could put like some style, like, my favorite, what's it? Opacity is pending 0.5, otherwise 1. Let's format this. Turn off the, make this in a way that I can actually see it clearer. I've clearly broken the formatting here at the moment because there's errors on the page. But the idea is you could like have some route component. I don't know, that's like based on the URL. And as long as this was keyed, right? As long as this was keyed to the URL, so basically whenever this URL changed, it re-rendered these children. You could basically very easily render have the current, like first initially, you hit something async and it suspends whatever. But like after the fact, when you change the URL, what you could do is you could basically keep this here and then you could render again keyed with this new URL. Notice it's not a function. And then until it resolves async, have this be active with this is pending signal set to true. And then once all the async resolves on the forked branch, swap in its content and run its effects and do everything. Like it's very easy with the primitives I just showed to build something like this. And you're like, oh, done. No use transition, so to speak. And you now have like preloading. So like when someone, not just preloading routes on hover, but like literally like transition without transitions, right? Forking, very, very simple forking here because you can just use this as a keyed fork. The problem is two things. Obviously this route URL would update before like the things, so you have that problem, the tab moving early. Of course, you can just like, you could do something like, this could be like future URL, and then you could do something like on complete. So like whenever it finishes the async and does the swap, you can do something like value. You can like pass back in the value again and then be like, look, you can go set URL now to the value. So you could like basically do something where it's like predictive. So then your UI stays outside on the old URL. And then once it's ready, you can update it to the current URL. And because this is keyed again, there's this detachment because if a future URL changes in the future, it's not going to change this up. It's keyed to that. The problem, because this basically works and it'd be easy to make in user land even, relatively easy. The biggest problem with this is what if like you don't want it to be keyed? What if when the ID params change, but like the query params, you want to be able to change without re-rendering the whole page? Well, then things get awkward. Like, sure, you can inject them from above, but when the future URL changes and the query params at the same time, the current reality will see that. So this very naive approach is simple, and it's honestly what Solid did in I forget what version we added transitions for real, 1.2. But like back in like early 2019, we basically added transition properties to our show components and basically worked like this. But this is better. It controls the scheduling of effects, could do this kind of boundary. But honestly, I think React's right about use transition. Okay, cool. That's perfect segue into the Svelte conversation. Yeah, I don't get persist. I don't get activity either. Persist is better. I mean, the thing is, you have to look at. There's more things that you can do than today. I didn't finish the React blog, but like they were saying that like maybe we'll do it for like saying client only or you know, etc. The rest of this blog is oh, actually, there's one more thing before this whole conversation. They're looking at automating effect dependencies, which is funny because I'm at a point where I'm like, we need to separate them out. Right now, the React compiler, you have to set your effect dependencies directly. These guys are talking about setting before, like using the compiler to figure out effect dependency. The funny thing about this is we know it's imperfect. So yeah, effects can be hard. Unfortunately, some hooks still think in terms of effects to life cycles. We found often confusion from effects you don't need. You might not need effects. Agreed. Blah blah blah. Most people don't need effects without dependency. I think it's better. Yeah. Do you know why this works? Basically, React doesn't care because if the compiler screws up on the effect dependency thing, it can always like default to like always running the effect every time. So like with this code, convert dependencies for you and insert them automatically so you don't need to write them. With extensions like ID extension and use a like you can provide a code lens to show you what the compiler inserts for times you need to debug or optimize by removing a dependency. This helps reinforce the correct meta model for writing effects, which can run anytime. So like they're framing this more as like an engine you can tweak in terms of like figuring out what dependencies. But you have to understand the default means that if you tell people they don't need to write dependencies, they're just not going to write dependencies until they find that something is either doesn't work or they don't find that their effect just runs over and over and over and over again. It seems very dangerous, but it will be interesting to see. Maybe people's developer flows are different enough that they're like always sitting there and like using these built-in IDE tools to like analyze how efficient their code is. Maybe that's something everyone does. So maybe this will work. Oh yeah, compiler ID extension, fragment refs, yeah, gesture animations, current stores. This is a big thing, possibly for like the tan stack type people in third-party libraries. Anyways, it's enough for this right now. I think those are the big headlines. It's just interesting because like compiled effects are hard. Like Svelte moved away from it. Their effects are runtime now. The compiling the dependencies doesn't allow any level of composition. Yeah, this is interesting. Anyway. I mean, you can ask questions whenever you want and interrupt me. It's all good. And I will probably answer you, but I am short on time, so I'm just going to blow through forward. But if something comes across and I feel like answering it, I will answer at any point. Okay, let's continue. Hopefully everyone, I think a lot of you have seen this. Asynchronous Svelte. You can now use the wait keyword in Svelte in your script inside derived expression, blah, blah, blah. Okay, by adding experimental async, sounds good. Let's try things async playground. You will find bugs. Yep, right. Background. If you did it on mount or in a wait block. Yeah, this works, but it's quite verbose and offers no coordination. If two components are both fetching, they will likely have independent managed error loading states, often resulting in janky UI multiple spinners. Yes, because it's not because no inversion of control. Like basically, this is what I was talking about before. Is like you can't combine them. One of the benefits of the inversion control suspense is that you could have like multiple different async sources and be like, no, they're part of the same block or the same conceptual thing. Whereas like a wait, you have to pass the promise to it, and that's that. You could hoist it up, but then you'd be awaiting the like your promise all basically at that block level and then passing all the individual values all the way down through. So like, yes. Brands like Swell could remix offer an alternative. Instead of fetching inside the components, we do your async work outside the components. For example, in a load function, this typically results in better user experience, blah, blah, blah. But it to its problem, prop drilling, blah, blah, blah. All the stuff I just talked about, core screen validation. Yeah. This is all why we didn't design Solid that way. In recent years, component frameworks have explored a third way of putting things in, right? Suspense and transition. I guess it is recent years. We released our first version of suspense with transitions back in 2019. So that's end of 2019, I think. Anyway, Solid has created reserved suspense transition as well. Vue has a wait inside script setup. We said sooner better renounce some few drawbacks in existing approaches. Yeah, minimal ceremony, want to write code, wait, flexibility, blah blah blah. Parallel by default. Starting to safely seem to be pure things. Yeah, this is an interesting one. If we overlapping, impact performance. Await is a very what's really cool about await is the consumer has to put it out there. You don't have await, as I said, as a key, it doesn't it composes by coloration. So like you can trust it at the top level. It doesn't matter. You don't have to search deep for a weight. Do you know what I mean? Like you know that if it's async, it's going to be like right there at the consumption point, which works quite well because you don't have all the other. You don't care what happens inside the thing you await, which makes it really good for the compiler target. Actually, I remember I was sitting at React San Francisco, whatever the last one there. I think it was 2022, was it, or was it 23? With Theo at the dinner. Before the conference where me, Tanner, and Ben from Astro were really, really harsh on server components. And Theo was telling me how much he really, really liked the new async components in in um, React server components, and I was like, isn't it weird? Yeah, but the thing that he pointed out to me, like because like it's blocking conceptually async. But what he pointed out to me was that where is this? This is review routing for future reactivity designs. Yeah, this is very old. He pointed out to me that like people don't really care; they just want to await. So like I basically was trying to design create async. And I was like, oh, okay, it could be memos returning stuff. Where was I? Concept layer. No, I already skipped past it. Where is it? Oh, was it not this one? Let me see. Just a second. Sorry. Let me see if I can find it. Maybe it was this one. Huh. Maybe it's not. Oh, I thought it was this one. I was trying to. Oh yeah, it's right here. I was like, wouldn't it be cool? Trying to appease to Theo. I'm like, wouldn't it be cool that we have all these async stuff, and this is before I had create async. I thought it was like memo but eager. If you could just have them all, do this, and then just write await in your code, and then it actually convert it into a bunch of these calls and be non-blocking, because we don't have to like trace for async. You can just know that 100% if you've seen an await, like you're free to basically wrap it in a create async call, which is a really cool compiler aspect of async await that is not true of so many other compiler hooks. Like this is one you can depend on. You don't have to worry like, is it a component, is it not a component, is it a function or whatever. Async is actually really easy to analyze and consistently do the right thing for it. So is await pool will be visible, overlapping updates. Okay, sorry, it was just something I was thinking about it. Design in nutshell. You can now use await in 3 places: top level component, derived expressions, or a template expression. We also use pending snippet to the smelt boundary, blah, blah, blah. Inside derived. Okay. To know if updated currently affect pending. Yeah. Does that make sense? Is pending basically, although it's more of it's scope injected as pending. It's not like asking which async is pending. Like, is this user pending? It's going, is this scope pending? Use case, most obvious use case would be loading, simple fetch. Yeah, and obviously you can trigger other resources, avoid waterfalls. Right, because these awaits are all separate reactive scopes. This is very similar to, yeah, it's an interesting one, right? You can inline it here, which is kind of nice, right? Because essentially without the compiler, you have to basically hoist out the fetching and then read the signal in here, where the compiler can just go like, oh, we can inline this, right? This is doing basically the same thing where this doesn't block this, doesn't block this. If you guys remember, I did on my async stream a bunch of demos where we could show basically that like with signals, there's no reason, because each thing gets wrapped in its own effect, right? That there's no reason to not do it. Actually, I think I have this right here. Is this the right one? No, this is the nested fetching one. This is showing how you can fetch in a component, in a child, all the way down, and that they don't block. So like, see, they all start at 0 and they all end at 2. So basically you can put a component in a component and have them all fetch. And because they're not, because essentially this has nothing to do with this, a separate expression, they can all independently not waterfall. Sorry, this is not the example I was looking for. It's a cool example. Let's see if I can find the example I was looking for. Projects. Parallel fetching. There it is. This is the one. Yeah, where you can put like comp A, comp B, comp C, and they can all fetch their own data. I mean, this could also be inline. Like I didn't need to make these components. I could have just like put the fetching up here and done them separately. And they again, 0 to 2, they don't block each other. So yeah, this is a very good quality of these sort of solutions, because technically they're using signals under the hood. There's some key differences. We're going to get to it, but the baseline is, you can see it kind of similar, because they don't throw. My understanding, not all work can be parallelized. Any await expression inside the script run before expressing the template, and then the sequence would you be expect. Though if X is subsequent updates, yes, right. Yeah, yes, you need necessary. Yeah, there's no way to avoid waterfalls when X is async. I think. Is X async in this example? Yeah. If there's a direct data dependency, you can't avoid waterfalls. That's fine. Okay. Necessary waterfalls. You wrote a whole thing here. Yeah, artist. Yeah, like these are not avoidable. It's better to both fetch it on the server near your database, so you combine them into a single thing. Agreed. Let's say, or use server components. Blah blah blah. Okay, that's fine. Async SSR pending. So yes, it looks like Svelte. Yeah, this is how they're going to get a lot of the topic we talked about earlier. They're trying to get async streaming automatically. SSR forking. We preload data, navigation before it even occurs. Tap it, import modules, load function around this paper is configurable, of course. Okay. For this is transitions, to best I understand. You make it work. Async group happens. It's like quickly and so forth. It sounds complicated, but in reality, it's not that different now. Async updates. We're already working on this. Right, client server utilities, server endpoints. Unless you want to create server end for everything you want to fetch inside. Oh, so they're adding use server as well. Interesting. I think someone shared a link to me what this looks like. Query act. This looks very familiar. Okay. Into it. I mean, this is just, I think, the obvious natural evolution of these things. I like it. Okay. There's obviously like more details I'm not seeing here, but type theory knows no start transition, and you saw it, you encountered start transition. Well, the funny thing is you probably haven't. Most people don't realize the router does this automatically. It's going to allow you to update state in this way. So we don't do that. Instead, we. Yeah, that's actually not how transitions work. The function allows you to update state in such a way the nearest manager doesn't follow. The way transitions start from the top. They basically say, when I start this state change, I'm going to essentially, I mean, React is re-render, but in like from the state change, like whatever component runs it, the suspense boundaries above don't matter, and even the suspense boundaries below don't matter that much unless they're new. Existing suspense boundaries participate in the transition all the same. So they basically just like move forward. If they hit a new suspense boundary, they're like, okay, it's fine, that will fall to fallback. But otherwise, what they'll do is they'll like basically fork the reality or fork the reactive graph or fork that and run the other reality off screen until such time all the async is resolved, excluding stuff in new suspense boundaries. But the important thing to understand is transitions are kind of like a global thing. The importance part, and I kind of showed that in my other example, is like if you go into a future URL and you just want to go update the URL to the future URL, you don't want tearing. You don't want like even if the main part of the page is lower, you don't want like the tab where you click to highlight the next page before it's ready. So it actually locks the state from the very, very top and has nothing to do with actual boundaries. The boundary part is only in terms of determining what participates in the transition of newly created stuff. Something doesn't connected given P state power prevented changes state from being reacted. We think that, okay. Instead of the state changes resulting in asynchronous work, always have their effects deferred until the async work is complete. Well, that work is ongoing. Effect pending is true and pending. Okay. Interesting. So they are doing something that's transition-like, but they aren't forking. So it's kind of like a locking approach, if I understand this, because what they're doing is they're essentially saying, okay, you can update the async state, and everything within this region or bounds is going to be not do its side effects until everything is done. So they're kind of doing, and then it's saying you can use this pending is true. So this is like implicit transitions without forking. Interesting. Okay, let's continue with this. It's possible that something distant can do this. The particular differentiation is reflected. We think this pro to the alternate which updates us. This for the in which case updates outside use. Yes, yeah. See, the thing that everyone hates is the random fallback to fallback. See, Solid's 2.0 solution's different than this. That's interesting because we're opting in to tear. Basically, there's only three things you can do. You can stay in the past, you can bail, and you can tear. Those are your three options. Transitions stay in the past. Felt's approach stays in the past. Solid's approach tears by default outside of transitions. That was the difference here. That's interesting because that has implications because that means their solution is based on bounds. I wonder, you know that demo that it was the wrong demo? I wouldn't be surprised if Svelte doesn't work with nested waterfalls. I wonder because the way they hold the effect, yeah, like I wonder if like I see the parallelizations of the await, but that's like block scoped to the same thing. Like I wonder if nested fetching gets affected. I don't know. I probably don't have the means at this moment to do this, but I think someone who's interested in this should probably see if you can do this example where you can have three components all nested in each other, all fetch data, and see if it doesn't waterfall. I suspect that might not be the case in at least the current proposal implementation. Just kind of things I'm getting from here. The other thing is overlapping updates that touch the same state must be applied in linear order. It's possible to imagine state members A is followed by its B with one. Since you then we show style values, such change that. Yeah, see, they're concerned like React about not showing stale values. So this, yes, async derives are eager. Yes, this is you get the diamond problem. In fact, do we still have the Excalibur up? Let me see if I can. I didn't actually use this today, but yeah, there's two problems that you hit when you're doing this stuff, right? You have the diamond and the flag, right? And if you have let me see, let's get in here. If you don't fetch eagerly, so you do a state change, and then if you don't fetch eagerly on both of them, there's a potential that you create like I guess that's only a throwing version. Their version doesn't throw, but if they still have to hold execution, right? Because if I'm understanding the Svelte solution, instead of throwing, when they realize that like B is async, they don't run D. But then if they don't run D, they can't discover C. So async has to be eager so that you know to run B and C eagerly. So even without throwing, like they're smart enough to not run, like basically because the compiler, they can add extra information. Solid's case, we don't know. So we just run it and go, woo, and throw away along the graph. But then, you know, the difference is effectively becomes a not a huge difference because okay, this runs, throws immediately. This Svelte's version doesn't run, but is aware that this doesn't need to run because it's async. You can't discover the dependency of C. You know what I mean? Like So like, yeah, the eager thing makes sense. Okay, let's keep on going. This really is the fact of sourcing in the trench coat. We've this an effective promise for the most part. You don't need to think about it. Blah 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 blah. Impossible create unknown derived and blah 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 blah. It's not possible. Its effects only executed inside other effects. Yeah, so it needs to be part of the ownership tree. Good point. Context is preserved in expressions. Interesting. Yeah, I because they're hiding stuff and using a weight, they think about it. Generally, we always assume that after like it's a weight is like bailing out of the synchronous execution, so we're not worried about it. But they're encouraging a weight. Yeah, okay. So no async drive by. So while you can do this, yes, that makes sense. Will then be a promise, not the way to why. Okay. Focus inputs are not overridden. Okay. Interesting. Yeah, there was a comment. I think there's a lot of really good discussion here. I think the key difference is the default behavior of opting into tearing versus not tearing. I'll talk about that in a minute. Um, where the search changes before the result of the previous one. Yeah, the problem. We'll talk about the yeah. This is yeah. Let me get to yeah. Okay, someone was like, "Solid user never use create resource." Blah blah blah. Very happy with create async. Create sync isn't part of solid, it's part of router, not important. The program model, blah blah blah, nothing create sync. But let's say here. Okay. Currently solid's resource are different. It's the same non-blocking, blah blah blah. I'm basically I think the problems that we're trying to solve with these solutions, and when we're talking about ergonomics around this, is first async isn't completely colorless in the sense that async values can be null in solid, where this solution that's being proposed here, the async values are not null because it's a weight. You know that you'll have the value when you get to it. So making it non-nullable is a big part of the solution. Obviously, Solid 2.0's version does that by throwing, but this is an important characteristic of the solution. The other thing is suspense being too eager to bail out is really easy to trigger suspense. It's a small async update on the page causing return to fallback. Using transitions is one way to avoid this, but most of the time people would probably rather just tear. This has led to stuff like use deferred value in React and latest in our resources. This is tearing. When you use deferred value or latest, you are tearing. The truth is 99% of people will never knowingly use transitions. They're mostly there for routing. The cases that Rich referred to in the forking section. So they aren't generally part of the experience of developing. However, aggressive suspense bailout can get people there much earlier than they intend. So yeah, basically, the Svelte solution has solved both of those problems. Like both the problems we have in Solid 1.0, which is the non-nullability, and this one here, which both React and Solid have, where the suspense and even Vue, I guess probably anyone who's done suspense so far has generally been really eager. But the way we're approaching the solution is actually a little bit different, and I'm really interested to see how they manage the flag problem. What I talk about the flag problem is Diamond. We understand the flag problem's a little bit different. It's when A has async that feeds into other async, and the challenge with the flag problem is that this is like a signal that triggers two things. So like say a user ID that fetches a user and then fetches user's post, but the user's post fetch requires something from the user record to also fetch it. So you create this kind of flag problem. The problem is if you don't block along the graph in a certain way, you have this challenge where, let's say users one, you fetched user one and you fetch your stuff, you're fine. And then you update to user two. This will immediately trigger both of these because they get notified. And then if B is will fetch user two, but it's possible C will try and, if you don't have like throwing or blocking or something, C will try and fetch using basically user two and user one's like other thing you needed to grab off them first. And then when this finishes, it fetches again. You get like a double fetch. based on that. Now, with Solid's throwing approach, this doesn't happen. And I imagine with Svelte's analyze approach, it doesn't happen, but it is an interesting thing because these are both very key problems to solve in this space. Because, like, if you try and be too predictive, like like get ahead of yourself, it's very possible to cause this double fetching problem. One thing, as I said, I really liked about Solid's current our 2.0 solution is we solve both of these problems. The downside of what we've been doing here is that actually, I don't know what the downside is. I guess the fact that async can be hidden, like you don't have to wait everywhere. I think there's interesting implications. I think the tricky part about this solution, I like the compiler part of it with the await. I think the tricky part is the blocking by default is challenging. It's called the type ahead problem. The type ahead problem is when you update state in a search box, and each character triggers async for a fetch. And what React suggests to do in this case is use deferred value. So, like, basically you can show the torn state as you type, and then the async part does it separately. Now, I'm the boundary primitive here might be able to manage it, but I think one of the hardest things about transitions is that people don't realize they're in a transition. If you click a button, it does something. Let's say you wrote the code to work a certain way and there's no async, and then everything's snappy and immediate. And then someone adds async somewhere, and then suddenly stuff stops updating right away. And yes, you can use pending or is pending or transition is pending or whatever to tell you this, but the person who wrote the original code and saying, why is my section slow, has no clue why this is happening. There was actually a JavaScript framework that went pretty far on this. The creator block DOM, I think it was called Odo or Owl, did this did transitions by default. And this was kind of like I looked at it a few years ago, and this was kind of like the challenge here, because stuff getting correlated that had no business being correlated. Now, using something like boundaries to set like a UI correlation probably is a saving grace here, because then you can say, like, I can assume stuff within this zone wants to be updated together. But it's a tricky problem to, like, I think we covered this last summer. It's very, very difficult to say by default stuff's not going to update when you do it. People expect tearing to the degree that, like, you almost have to always just give them tearing as the default. Bailing, as much as I hate it with suspense, is really awkward. You know, the way it wheels up. People sees their stuff responsive. We get issues on the router almost monthly where people are like, I click the next route and it takes forever to load. And it shows a current page and your router's slow. And it's like, well, it's because it's using a transition and you guys aren't using the is pending, essentially. That's an example where we opted into a transition without basically, I mean, we tell you in the docs, but who reads the docs? You know what I mean? Like, we basically said, like, hey, this stays in the past, and, you know, that's how it works. It's interesting when that implicitly can happen literally anywhere. I think my guess, given that Svelte's community and what they're into, I think this might be. I can see communities that would have no problem with this. Like if Elm did this, everyone would be like, yes, this is the best way possible, blah blah. But I feel like a community like Svelte's might find this a little bit like it's the correct thing to do, but it's also like maybe the non-obvious thing to do. There's a tension here. Yeah, that's interesting. When people start blocking, like, no, I mean, there's that part too. I mean, but I mean, you can't win. You either say, yeah, I mean, this again breaks the normal semantics of JavaScript. I think actually, Rich, we responded to my comment along this lines. Where did he say it? Have you see here the repost. What's the promo around in this case? Just the fact that I'm not dealing with promises in a way that feels JavaScript native, but rather via framework abstraction. I totally understand why it's the way it is. It's very better taste, but I don't think it would be right design for style. I do like how aggressively created async appears to discourage waterfalls. In the worst case, our design trade-offs a little more performance or ergonomics here, though on the flip side, it means that people are encouraged to learn patterns and to avoid waterfalls that apply to all their code, not just their components. The JavaScript native thing is obviously a minefield. So all this transforming your async code and doing all sorts of things we haven't seen, but React and Solid throwing to trigger suspense feels inequivocally magical. Yeah, it's interesting, right? Because the core idea behind the throwing is trying to add basically algebraic effects, and I say basically, which is hilarious, to the language. And I didn't know what algebraic effects were until I read the very great Dan Abramoff blog about it. But this idea of the ability to use basically try catch to remove coloration of stuff, so you can basically write code in a way that seems sensible, and then if it has problems, where it can't do what it's supposed to do, it asks the parent how to resolve it. And in a sense, like, that's what try catch is. So if you come from it from a functional point of view, it makes perfect sense. We don't even throw promises, we throw errors. But it's still the same conceptual thing. Like, don't get me wrong, it is weird to like view a world where you're like, where you go, I'm going to try and do this thing, and if it doesn't work because the value isn't ready yet, that's an error, and we'll try again when the error is resolved. It's in some ways, actually, sorry, that makes a lot of sense. But no, like, it's kind of like people don't expect that using errors that way to be embedded into their programming model. So yeah, I mean, it's interesting because this definitely has a lot less ceremony around it. As I said, this is a bit largely an ergonomics thing. But the decision for like to hold or not to hold, or fork or not to fork, and all that, I think that those kind of decisions can be made independent of the API. So my gut here is that we'll see how this progresses, and like, but hold by default, I think, is confusing. Like, it's just very, very confusing. People just don't see it coming. And I'm like, as I said, if it's just the router doing it, then you're like, the router better shout it in the docs. If it's like anyone does, like an await somewhere does it, like, it's tricky. I don't know. That's my only feedback. I think the design looks great. I think the fact that they're exploring fine-grained RSC style, like, stuff, like all these pieces are like very much needed and welcome and stuff. I think it's pretty sweet. I think the fact that they have solved the exact same problems that I was solving, in terms of, parallelism, colorlessness, removing sense, and came up with something like this is really awesome. I think Svelte developers will get like big benefit from using this API. I think even that's true with us too. I think there's still a lot of like devil in the details in terms of refinement here, and we'll kind of see how this plays out. But I do like the idea of like getting rid of used deferred value or like latest, and while still being colorless, which is, as I said, something that we've done also in the Solid 2.0 design. Basically, I think the details that are going to matter to that I'm going to care about, less about the hold forever. I'm really interested if the nested components scenario works, because killing the waterfalls and solving the flag problem at the same time was the point when I finally was like, this is the solution. And I actually have to thank Dominic Ganaway for that, because he was kind of put like, I've been, you guys have seen my stream, I like had like dozens of these like articles that we've been talking about, and we talked about this holding, no transitions, yes transitions, hold, block, all the different variations for like months. And then Dominic's like, I think we have a solution with Svelte where we don't do it. And I was like, I went through there, I couldn't get it. And then it coincided with some work that I'd just done with Dev. And then it was like, bang, the idea that you could hold inside the graph, yet tear on the edges, automatically basically solved everything in one go. But I mean, there's always going to be trade-offs. One of the biggest trade-offs on our approach, for example, is it's possible for people to use stuff in event handlers and not trigger suspense. I think this is much more component-centric. The way they hold it basically means that it's just not possible to hit some of those kind of scenarios. But I think on the other hand, it means it's not quite as transportable. It's not quite as granular. But I mean, Does that matter? Probably not. Anyway, yeah, expect waiting to blocking normal JavaScript. Yeah, sorry, I know I already talked about this, but that was actually the problem when I talked to Theo. I eventually dropped it. I was just like, when someone sees a way to wait, they're gonna like it just messes with their brain. I can't do that. That's all ultimately why I didn't. I think what I liked about this approach the most was that it's not a stretch to convert this into generators for SSR because people have already marked the await in their templating. You could literally like basically just like yield it at these points, and your SSR. I told you how we were simulating generators with signals. You could actually compile to generators with this like dirt simple. Like basically, the developer is telling you where to put the yields. It's very smart. I don't know if anyone's seen the Dust template language. Template, yes. It's old. LinkedIn created it. It was like one of the first streaming templating engines. You're not going to see it. It basically had a very similar way to essentially to like block out right in the templating language, and that's what this makes me think of, which is I think really, really powerful. Okay. I don't know if I have anything else to say about this one. I think the defaults in terms of holding are interesting. There's going to be slight differences in this model. So these aren't the same model exactly. So it'll be interesting to see how they play out. I think they both solve the React problems though, just in slightly different ways. So I'm still on team transition though. I think you have to know when you want this behavior. Like I think it's funny because I'm saying it's going to get hidden in routers anyways, but I think like you have to like be aware that this is happening. If someone just like throws some async on a page, it is very disorienting. Maybe not as disorienting as having your whole page blow up into a fallback, but it's disorienting when you have no freaking clue how async got introduced to your system and breaks it. That was one of my big goals with Solid, is because if any signal can be async the way we've designed the system, I have to make sure that stuff continues to act predictably for the people who aren't using those features, or who are even in the same project with people using those features aren't using it. Like keep parts of the isolation thing. That isn't always completely possible. If someone say loads the data that you need to show your component, then yeah, it's going to take a minute to get that data. But not, or a second to get that data, not a minute. I hope not a minute. But it's not like a matter of like some, because things just happen to be sitting next to each other. I don't know if I need to go any more on that topic. I covered almost a complete stream on why transitions by default were really, really awkward. So, because honestly, I would love to get rid of the need for transitions. It was last summer. I wish I remembered which one that was. Signing transactions. No, I think it was the one when we were talking about consistency first. Towards the end of my, I asked if there are no spends. Yeah, it might be worth a reread again, but implicit transactions. Like every setter could cause a transaction. How would you determine if it was pending, and how would you show it? The signal, blah blah blah. That's fine. Yeah. Important to understand transactions aren't often out on read. Everything's complete because the latest React has this new suspense boundaries, type ahead problem. Implicit transactions would, yeah. If anyone wants to read more on this subject, I did a stream on this too, but I'm gonna just drop this in here. Okay. What else do I got on my list here? Oh yeah. I got one more thing. That's related. I saw this. I thought this was kind of interesting. Dan Abramoff, cells can implement concurrent rendering in the future. Because this forking section is completely what concurrent rendering is. Kind of love that there's barely any hint that this forking is what React started 7 years ago. To the ridicule of the style community. Who needs that? I'm much more excited the bitter the goals upstream needed. Yeah. I mean, this is I remember when I came in defense of this, I couldn't believe everyone was lambasting React for creating transitions when, like, yeah, the fight credit and friend are petty, everyone's experiencing, blah blah blah. You know what you're thinking, blah 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 blah. Without the ability to delay updates pending coordinating, it's extremely rare. We never said we just took a long time to design met our threshold, but it's we don't really talk priorities, and I'm not aware of pre-existing metrics and what we have in mind now. It wasn't just you, but I'm just spreading them out is also miscarried to the future. We worked was an ability to compute free tree without committing. That's quite literally the forking section describes, of course. Yeah, because everyone, it's part of this is the React's team's fault for showing that stupid radar. That was never the coolest part of that demo. Everyone was like, "Oh, look how you can do the 3D thing," and Paul Henschel and all this. But the coolest part about Dan's demo from was when he was switching between the tabs, and it wasn't changing to the new tab till it was ready, and it was showing the pending state. Like that is the coolest part of that demo. So funny, it's like not what other people noticed. Yeah, it is the same thing. Yep, his Iceland talk. We talked about single CPO and IO. This is what they call IO bound. Yeah, it's arguably the first mainstream UI forking that shipped. Yeah, they shipped it in Canary first. We released it before React released it. I was so sold on this. I mean, this is not. I'm giving them all credit though. Like I saw their version and then released it to production before they did. Yeah. Anyway, as I said earlier, I think we're going to see more of this. I think this is one of those topics where React got it really right, and I think we're going to see with resumability and quick in like 5 years, people are going to be talking about this similarly. All right, how's everyone doing? You guys still alive out there? I'm almost done with what I wanted to cover today. With my new stream time, I can only stream till about 1. I think there's been a lot of interesting stuff developing the last little while, so it's cool to see that. I had one other interaction with Dan on Blue Sky around server components, because people are still kind of arguing about it. Because Dan's been really doing a ton of blog posts over Reacted.io, functional HTML, with use client doing impossible ones. He's basically since here React for two computers, he's basically re-implemented server components from a different philosophical standpoint every week, and see which one clicks. Where is it? Blue Sky. This one, love your article. I'm not convinced it's the way to move forward. You want two worlds separate. People like clear bet. You want to keep the world set the two environments differently while context, blah, 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 the connection between them, blah, blah. You actually can statically enforce boundaries. So importing something on the wrong side will refuse compile. Yeah, something worth noting. There's no need for throttling because your server isn't renderable in JSX. So it's not going to accidentally hit the server while rendering. Yeah, so because there's no weird cascade happening here. Regarding caching, server no longer cross-communication. We're going to test server function. Strong disagree that they solve this. I'm not aware anyway that they would force a single round trip across modular code, which is one of the main things that ensures. I mean, you because of the hoisting, you can. Single flight mutations is something that we can do. Take this down. We're at the source. Okay, yeah. So they're talking about. I mean, there's two different ways you can solve this. One, yeah, what he's talking about. Let me see if I can get it here. He's talking about, yeah, like data, like having a parent fetch the child, right? And like basically he fetches some data up here for the list, and then each host also fetches its own data. I get it. So cascading n+1 problem. And the answer is like, yeah, I mean, there's a couple ways to solve this. One way, if it's hoisted like route, you can obviously like have all the server functions basically cascade, like build onto the same request. But we're assuming that they aren't discoverable because they're nested. Like you have to fetch the list to get the list. So yeah, how would you know which ones are sure? I think the reason that Right, and then what's the Dan say? I think I have an entire list of posts for you, each with some limit. You'd have to make the one request to get the IDs and then do 30 parallel requests. I think the reason this, yeah, so Dan's like, look, the get the cascade, you have to do the one request and then you do all the requests. And my response to this was, like, I think the reason this argument never carries is because people have been solving this problem since the beginning. GraphQL is a solve, hoisting is a solve. The only thing people don't intentionally do is make 30 parallel requests. And a trivial example can always avoid it. The solution in all cases involves building up a larger data set in a single request on the server, which becomes more specialized to that specific part of the UI. So you do make server components in a sense, maybe made of JSON, but now you have two locations to update when any code changes. It's not like MVVM versus components. What I mean is, like, MVVM was basically the component model. View models are basically components, except because the view model tree was separate from the model tree. When you updated like what data you needed for the component in the server, you'd have to go over to the model tree and update it, and then you go over to the view model and update it. So you update it in two places. So in a sense, if you go, okay, I'm going to be getting a list of users, and I know that I need to get all like cascading thing. You're just going to make one server function to get the list of users with the fields you need, and maybe that's configurable as an argument. There's a lot of options of how you can combine this into a single request. But generally speaking, because this location needs these fields and this other location needs these other fields, you are in fact creating a kind of specialized data set. That means that, like, when you change the fields, you have to update it in two places. I think the composition argument is fair. The part that is less obvious is how easy it is to have multiple trees on the page that can entwine. What if you don't need to update the whole page on every mutation? It's a lot easier to picture that in a decoupled model. And I think this is really where the crux of this discussion has gone to now, because essentially we've gone to a point now where people, I mean, you can see, yeah, you can serialize stuff, server components, sending UI, interchange it all in a single request. That's great. But when you have to go change something, when your app is actually something that updates frequently, more frequently, maybe a dashboard, maybe something, it's very hard to see how you don't just like throw out the whole page every time, because it's all part of a single tree. Basically, the same superpowers and strengths that came in here to like allow you to do this single tree also means mutation isn't granular. So a lot of people are looking at, like, you can use the route level. Actually ends up being a very commonplace. I think Next's app router, you can, each nested route section can basically act as its own independent tree. You don't have to do the whole page. You could just do it from the route section. And I think what's happening is, if you have, it's not about interactivity, but pages that change like dynamicism significantly enough, it's very hard for people to see how the single tree, like, basically they're kind of at odds with each other. The thing that makes this solution so great is that it entwines everything, so like you don't do multiple requests. But the thing that makes it so terrible is it's hard to break it apart. So this tension is basically, I think, where we've been sitting. Like, it leaves people like Tanner trying to figure out how you can add multiple React server component trees to the UI, which then again also defeats the biggest benefit of React server components, which is the ability to, combine the requests into a single zone. But I think that's where the tension is. And then maybe if they find a good balance for it, then like people will be happy with that, and that will be the magic. Uh, anyway, yeah, I don't know. I read an interesting blog post about server components. Similarly, I'll share this one. It was called "Server Components Giving You Optionality." Just to kind of wrap up here, it felt like it was related, even though it wasn't, to like the conversation we're having. The whole idea was that, server components basically just give you your code runs on the server client, meaning you. Okay, what does it say? With traditional rendered CSR apps, your code only runs on the client. That's trading off UX or more elementary DX. Generally use dashboard style apps. With SSR, your code runs on both, meaning the same code. With the RCs, you can have full access to the prior two paradigms. Yet add one more, your code can run on the server only. It doesn't seem like a big distinction, but it actually major ramifications. It does. I agree. So yeah, universal isomorphic seems to be noticeable. The data, blah blah blah. But ours has to, it has to render on the server and the client. What server code must run on the client? What if the same code run on the server? I mean, there's lots of ways to run code on server. Yeah, I and then they're talking about RCs without the optionality. Some pages have to render statically thing. Yeah, I think the premise here is like the cell. I think the challenge here are Cs don't come at a zero cost. They require rethinking how we structure app sites, right? Because the structural aspect is actually the whole like concern. Tooling build systems are more fraught. That's fine. That doesn't matter. So is SSR. I believe for now, RCs are a tool for front end professionals. Expert Swiss Army knife that gives us fine tune. The only thing is they don't like they give you fine tune control if you assume that the basis is there's a few problems I think the React team might consider solving for the RC handoff that might do like if there's a way that you can precede like really easy pattern for preceding the data from the server from the RCs and then like update and mutate it from the client afterwards. I know that breaks the consistency of the model, but I'm wondering if that would help. Um, like even though it lets you choose which environment, the truth is your client code still needs to go to the server. Like you don't eliminate that need with RCs. Like suddenly you have two different data. You have an RC data path and then you have a client data path. So it is very much putting both options. And in a sense, that's an expert level thing where you can have them both things. But the problem is when they become hybrid, everything becomes client components. So it's like there's a mismatch here. I think this is the argument I would have made for RCs a few years ago when I didn't understand them as well as I do now. Um, the fact that you can do both and all put it side to side is incredibly powerful. But the trade off of how they like the devils and the details of how those things wire together. I think this is why it's like there's a lot of people coming to them from a very client side perspective, and it's just pure hurdle, even if technically speaking, incredible capability to do even more. I missed this, and that's the part that I probably should spend more time on. I was reading the description, and I admit that from that alone, it sounded like a lot of the coordination efforts were in a blocking, and that might be the wrong assumption. W- I, I might need to. No, I don't want that. I might need to actually. Is there an example? Yeah, see, because these when I saw these examples, I was like, okay, this is you know, yeah, yeah, I think I need to make examples, like spend more time on it to actually like and I said this when I was covering it, to actually like see the repercussions of it. Yeah, like there was those I saw those demos. Maybe there's like I've read a lot of the discussions here. It's just there wasn't there's a discussion about is there a type ahead? No, anyway. Yeah, the interesting question with server components generally comes is like, what if those islands make up 80% of your page? How much does that change your perspective on it? Yeah, well, we're gonna server components we spend a lot of time on, which is a kind of a different thing. And this felt async stuff. It was just at the beginning, so I think we'll probably spend more time on this as it fleshes out. If people make um, more examples and um, demos of like how these things work. Um, the one thing I did want to try, Dom, that I didn't get to try is I didn't see how nested fetching works. Like if you have a component that fetches data and another component inside that fetches data, not based on that, just completely independent data. Like so, not like a cascading reactivity, but like like basically two completely independent fetches that are nested because of UI. Yeah, I mean, yeah, I mean, it's like this is the kind of tension, right? You can get all the data in one round trip, but then what if you don't want it all in one round trip? Like there's an interesting architectural tension. Okay, let's see. I'll bite. I've got about 10 minutes tops. Let's see if I can. Let me see if I can understand this because maybe this example will give me a better insight into what we're doing here. Okay, but maybe this is just okay. So we put a boundary around. We have three components, and each component fetches its own data. So this is parallel fetching, and then they all take 2 seconds. So how do I just refresh? Is there console here? Imagine this is just imagine this is oh, okay. I see. Fetching and wrapper fetching. Yeah. I see what you're saying. So let me because wrapper, where's wrapper? So the children are fetched in parallel, these two, but the wrapper. Okay, gotcha. And this delayed has nothing. There's no coordination. Okay, so yeah, yeah. I think it'll be interesting to go into the more details in the future about um, how these things work. Oh yeah, yeah. Sorry, Dom. Maybe if you send it on Discord, I can see if I can grab something. The YouTube chat filters out links. I don't know if you have access. Yeah, Discord's probably best if you have it if you're still around. I see it's gone from effect pending to snippet pending. Okay. Okay, gotcha. Yeah, which I'd have to manufacture this. I'd have to mess with this demo a bit to actually make it do that. We'd have to actually have like a driver that drove. Like it doesn't even. You'd have to drive all of the fetching because to actually see it. Yeah. Oh yeah, you and Jay Larky are going back and forth. I wouldn't worry about it too much. He knows what you're saying. He sometimes likes to push it a little bit. Everything is server first until you plan. Yeah, I think this is a good way to approach, and I think more people should be using Astro honestly, in general, because of like there's a whole category. It's just interesting that React typically catered to the application developer. So now we're kind of in a zone where people like the primary audience is like kind of missing, going like, how does this work in my thing? It's not just the mental model of it. It's literally like even the if you give them the use case, you're just like, what's this supposed to look like? I think it's a great exercise. As a framework developer, it's always fun to go through that exercise. Like people gave me some of the hardest effects to split, and they're like, how do you split this effect? The sad part is sometimes when you go through that exercise and you end up with like better code, the thing is that you realize that the developer would have never got to that solution in the first place. Yeah. Anyway, with my new stream time and stuff, I got to wrap up here. Eventful stream. I think we got through a lot of stuff. So that's good. I might be a little while again. Getting ready to move coming up here, and I've been, as I said, working on a new compiler for the solid SSR. It's so funny because I know writing this that like if we go to like something like resumability, we'd be writing a new compiler again. The key part is that the client and the server match, which means that hydration and server outputs have to go lockstep, and the client only stuff doesn't actually matter as much. It can be like optimized for its use case. So like it is a very interesting how different like the world goes when you start focusing in on those kind of specific optimizations. I'm hoping we just find a happy middle place. I was really hoping I could just skip this topic for now and just get out all the really cool client side stuff we've been working on. But it looks like Solid 2.0 has to be the complete solution. So, like in terms of, I mean, it was always going to be complete, but it has to actually include all of the stuff updated to work in this model, which is fine. It's gonna take a little doing. I mean, I don't know what that means. I mean, I guess I once accused Misco of not having actual resumability because his components reran because they were VDOM, and then he added signals. My pseudo resumability, like the problem with the resumability of the topic in general is like you still at some point have to convert the serialized data back into a signal graph. Is that different than constructing it while hydrating on the page? Do you know what I mean? Like you don't actually have to, like you still also have to add the event handlers on the, like you still have to actually do the basis of hydration. It's whether you use a component tree closures to do it or you have a routine on the optimal data set. The biggest difference is you don't have to run the computations, right? So like, well, as I said, what's actual resumability? I don't know. Like what if you ran all the components but didn't have to run any of the reactive scopes? Is that actual resumability? I think Quick's definition includes the ability to lazy load code. And I think that's probably more interesting, which is you basically have to turn the graph on its head. So the effects are the top of the graph, not the component tree. And I think that's the key part. Because you want to have that ability to actually execute things lazily. Not necessarily load it, but execute it lazily. Like things become signals lazily. A lot of complication there though. So yeah, I don't know. Maybe something like resumability. Dominic got the link. I will give it. I literally got just a couple more minutes left, but let's see what here. All right. Input, bind value city. Okay, sweet. Yeah, so this is the type ahead problem. This is what I was worried about. France. Sorry, no. What am I looking for? We did Paris. Let's do London. Right. Not sure. Am I introducing a different way? There's like a lag that I'm introducing somehow. I don't know if this is the right. Oh, I'm not screen sharing. Huh. Yeah, sorry. Screen share. Thank you. Yeah, sorry. So this is the type ahead situation where you have a city. Let me reload this thing. And then you have the search results for the city, right? Paris, toggle. Okay. I think this is the type ahead example. So if I delete it, London. Yeah, there's some kind of delay coming in. I don't know if that's intentional. Let's see if I can drop it in one thing. What's another city that might have toggle full details? Can we do New York? Maybe not that. Let's try London again. Oh, I see. It's what you're trying to. Oh, okay. Okay. I see. So if I, okay, I didn't do it fast enough. I'll get it. I'll get it. I'll get it next time. Okay. Now, if I go to London and I toggle it, Tonga. Cool, and it's felt to like 3 seconds. Okay. Paris. Yeah, I don't know. Maybe I'm just not quite getting the demo. I gotta go now though, so I guess I'll have to pick this up another time. Maybe I'll have you back, Dominic, when we're a little bit closer on release on this stuff, and we can talk about it. Anyway, yeah, I gotta go pick up and do stuff. Yeah, no, for sure. I demoed something earlier today that was like that. I had like an off-screen component, and it was just like it got stuck in loading forever, and I was like, oh, oops. It's all good. Yeah, really exciting stuff that's being worked on right now, like redefining how we look at async in libraries. And to be fair, as I said, React did, in my opinion, just kind of start the ball rolling in a lot of this stuff. But when you combine this with signals and fine grained reactivity, there's just like this superpower that completely changes expectation. You don't have to like block the world. You can do things more granularly. It can flow much more intuitively. So I think this is a brave new world. As I've been saying, the journey into reactivity is still fairly new, and this async area is very, very exciting. So it's very, very cool to see progress here from all over the place kind of coming into the forefront. So Angular recently actually had their resource proposal and stuff, so very, very excited about where this stuff is going. Anyways, that's it for the stream. Hopefully I'll stream again sometime soon. So until next time, let's see, is there anyone to raid? Just only people I'm following are magic streamers. Sorry guys. I will see you guys around.